How you doing? Thank you for tuning in to this here video presentation by Mr. Larry Whittington, or as he want to be known, Mr. Whit. Mr. Whittington's know all about mathematics, and that is why he founded the Fort Bend Tutorings. Today we're going to learn about word problems. Not the kind where you curse people out, but the mathematical kinds. The kind I don't be understanding at all. Alright, get your ink pen and your pencil ready. Take notes, because you finna learn from Mr. Whit.
Hello ladies and gentlemen, this is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about mixture problems. Well, ladies and gentlemen, there are two types of mixture problems. You can have mixture problems that deals with percentages, and you can have mixture problems that deal with money. Today's lesson is going to be about dealing with mixture problems that have percentages involved. Alright, so let's start out with number one, shall we? We have how many gallons of 5% acid solution should be mixed with 20 gallons of 10% acid solution to obtain an 8% acid solution. So anytime I'm setting up a mixture problem, ladies and gentlemen, I'm going to use a table. That's right. I'm going to use a table to help me create this equation here. So I'll have my amount. I'll just label this AMT, and this is going to be my percent, and I'll just label this as the final mix. Please note, ladies and gentlemen, that it's always the first column times the second column that'll equal to my third column. What I'll be mixing together is going to be a 5% acid solution with a 10% acid solution to obtain an 8% solution. So I have 5, 10, and 8 percentages as my labels for the rows. Since I'm asked to find how many gallons of 5% acid solution, I don't know what this amount is going to be. So this amount is my variable X. It's my unknown. I am told that I'll have 20 gallons of my 10% acid solution. In order to find out the amount that we'll have at 8%, you'll simply add these two values together. So it'll be X plus 20, just like this. All right, we're going to convert our percentages into decimals. So 5% written in decimal notation is going to be 5/100ths. I'll then write my 10% as 1/10, and then finally 8% written in decimal notation is going to be 8/100ths. As I said before, your first column times your second column will always equal to the third column. So X times 5/100ths is going to give me 5/100ths X. 20 times 1/10, that just multiplies to give me 2. And then multiplying X plus 20 times 8/100ths will give me a result of 8/100ths times X plus 20. I'll write it just like this, okay? It'll be this last column here, ladies and gentlemen, that's going to be my equation. So writing it out, we'll have 5/100ths X plus 2 will equal to 8/100ths times X plus 20. And this is going to be the equation for the word problem here. Solving my word problem, I want to get rid of these decimals. So I'm going to multiply each and every term by the smallest place value, which is 100, the hundredths place. So multiplying each and every term by 100 is going to look just like this here as I multiply each term by 100. All right. And what that'll do is get rid of my decimals, ladies and gentlemen. I don't like dealing with decimals, so I like to get rid of them. So multiplying by 100 moves the decimal 2 places to the right. So 100 times 5/100ths just gives me 5x. I will be adding 100 times 2, which is 200. And this is going to equal to 100 times 8/100ths. That gives me 8 times X plus 20. And now I have an equivalent equation without any decimals. A happy camper I am. From there, I'm going to distribute, ladies and gentlemen. That's right, my favorite property in the world. And therefore, I have my arrows popping. So I'm going to be bringing down 5x plus 200, which equals 8x plus 160. Solving for x, ladies and gentlemen, I'll be subtracting 5x to both sides of the equal sign. All right, and doing so, I bring down 200, which equals to 3x plus 160. From there, I'll be subtracting 160 to both sides of my equal sign, and I end up with 40, which equals to 3x. From there, I'll be dividing both sides by 3 to find out that I'll need 40/3 gallons in order to get this 8% solution that I want, ladies and gentlemen. Now, if you want to, or if you have to for that matter, you can convert this improper fraction into a mixed number and you'll end up with 13 1/3 gallons. All right, so that's my value of X, and this is the answer to problem number 1, ladies and gentlemen. Let's check out the next problem. All right, in problem number 2, it says Samir has 2 solutions available in the laboratory, one with 5% alcohol and the other with 10% alcohol. How much of each should he mix together to obtain 5 gallons of an 8% solution? All right, so let's talk about Samir, ladies and gentlemen. We know that first of all, we'll have an amount and a percent, and that's going to equal to my mix. He has 2 solutions, ladies and gentlemen, so I'm just going to say the first solution plus the second solution is going to end up with my total solution here, which is going to be an 8% solution. All right. I don't know the total amount I'll be using for the first solution here, so that's going to be my unknown value. I do know that the total amount, or my 8% alcohol solution, is going to total 5 gallons. Since I don't want to use a different variable, ladies and gentlemen, I want to try my best to write one equation with one variable. All I'll need to do for the second amount here is simply take the difference of the total and the unknown variable here to give me a result of 5 minus x for the amount that I'll use for the second solution. We know that the first solution has 5% as a solution, so I'll write that as a decimal, so that'll be 5/100ths. The second solution, which is at 10% alcohol, will be represented in decimal notation as 1/10. Finally, I know I'll end up with an 8% alcohol solution, so this is going to be written as 8/100ths. Remember, ladies and gentlemen, your third column is going to be the product of the first column times the second column. So multiplying x times 5/100ths, I'll end up with 5/100ths x. Then multiplying 5 minus x times 1/10, I'll have 1/10 times 5 minus x. Then multiplying 5 times 8/100ths, we'll just end up with 4/10ths, just like that. I'll be using this last column to create my equation, ladies and gentlemen. So, writing out my equation, I'll end up with 5/100ths x plus 1/10 times 5 minus x will equal to 4/10ths. Solving my equation, my smallest place value is the hundredths place, so I'm going to multiply each and every term by 100 in order to get rid of the decimals. So this is going to be 100 times 5/100ths x plus 100 times 1/10 times 5 minus x, and this is going to equal to 100 times 4/10ths. When multiplying each term by 100, that will move the decimal 2 places to the right. So moving this decimal 2 places to the right, I end up with 5x plus 10 times 5 minus x, which is going to equal to 40. Then I'll be distributing the 10, so I got my arrows popping, ladies and gentlemen. So I bring down 5x plus 10 times 5, which is 50, minus 10 times x, which is 10x. Oh, yes, it is. And then you bring down your equals to 40, right? From there, I'll be combining my like terms. 5x minus 10x is a negative 5x. Bring down that positive 50, which equals to 40, ladies and gentlemen. Then we're going to subtract 50 to both sides. Oh, yeah, just like that. Check me out. Check me out. I end up next with negative 5x, which equals to 40 minus 50, which is negative 10. And then what will you do? What you going to do now? That's right. You'll be dividing both sides by negative 5, ladies and gentlemen. You got it. We'll find out that x equals to 2 gallons that we'll need, ladies and gentlemen, at 5%, all right, alcohol. And we'll also need 5 minus x, that was the second amount. So that gives me 5 minus 2, which will be 3 gallons that we'll need at 10%, ladies and gentlemen, alcohol. All right, so there you go. Those are your 2 values of your solution. And here comes a red box. I like putting red boxes around my answers. So there you go. All right, that's problem number 2, ladies and gentlemen. And now we have problem number 3. A gallon of vinegar is labeled 5% acidity. How many fluid ounces of pure acid must be added to get 6% acidity, ladies and gentlemen? So here, we're going to once again start out with our amount, the percent, and this is going to give me my final mix right here. The rows that I'll need is going to be 5% acidity. My next row will be my pure acid, and then I hope to get a 6% acidity solution here of vinegar. The next thing I'll be doing, ladies and gentlemen, is writing down my amounts, all right? Now, keep in mind, ladies and gentlemen, that they told us that we had a gallon of vinegar, and then they're asking us how many fluid ounces. So notice that our units of measurement are different. Fluid ounces and gallons is not the exact same unit of measurement. And since they want my answer to be in fluid ounces, I'm going to convert 1 gallon into 128 fluid ounces. which is the number of ounces that is in 1 gallon. I don't know how many fluid ounces I'll need of the pure acid, so that's going to be my variable x. Then to find out the total amount of the 6% acid vinegar, I'll end up adding x plus 128, so it'll just be x plus 128, just like that. All right, we'll be converting our percentages, ladies and gentlemen, into decimal notation. So that means that my 5% was going to be written as 5/100ths. And anytime you have something pure, ladies and gentlemen, that's going to be 100%. So pure acid is 100% acid, and 100% written as a decimal is the number 1. The 6% will be converted into decimal notation to look like this. It'll be 6/100ths. Remember, it's your first column times your second column that will always equal to the third column. So I'm going to write this as 5/100ths times 128. All right? I'm not going to stress myself out multiplying that out right now. But I will have fun multiplying x times 1, because that's just x. Then multiplying x plus 128 times 6/100ths, you'll end up with 6/100ths times x plus 128. And this last column, ladies and gentlemen, is going to help me create the equation. So check it out. We'll have the following. It'll be 5/100ths times 128 plus x equals to 6/100ths times x plus 128. Solving my equation, I don't want to deal with these decimals here, so I will definitely be multiplying each and every term by my smallest place value, which is 100, the hundredths place. So I have 100 times 5/100ths times 128 plus 100 times x equals to 100 times 6/100ths times x plus 128. All right, just like that. From there, ladies and gentlemen, multiplying by 100 moves the decimal 2 places to the right. So I'll end up with 5 times 128 plus 100x equals to 6 times x plus 128. From there, I'll be distributing, ladies and gentlemen. I have my arrows popping for the 6 right here. So now that I have my arrows popping over here, ladies and gentlemen, 5 times 128 gives me 640 plus 100x equals to 6 times x, which is 6x, plus multiplying 6 times 128 gives me 768. All right, from there, ladies and gentlemen, we will be getting our variables on one side of the equal sign. So I'm going to do the following. I'm subtracting 6x to both sides. So I'll be bringing down 640 plus 94x is going to equal to 768. From there, I'll be subtracting 640 to both sides of the equal sign. I'll be bringing down 94x, which now equals to 128. From there, ladies and gentlemen, I'm going to be dividing both sides by 94. And so x equals to, dividing 128 by 94 gives us a result of 1 in 3,600 fluid ounces, ladies and gentlemen, and that is rounded to the nearest hundredths place. And this is my answer. We'll need 1 in 3,600 ounces of pure acid, ladies and gentlemen, in order to give us our result. And that's the answer to problem number 3, just like that. All right, problem number 4, ladies and gentlemen. Babs has a solution containing 12% alcohol. How much of this solution and how much water must she use to get 6 liters of a solution containing 10% alcohol? So once again, ladies and gentlemen, I have my amount here, I have my percentage, and I got my mix. And I know that Babs has a solution containing 12% alcohol. So this is going to be my 12% alcohol. And I know that she's going to have some water. All right. And I want to get a solution that's going to be 10% alcohol. So this is going to be the setup here. I don't know how many liters of 12% alcohol she has. So therefore, this is going to be my unknown value. I do know that the total amount I'll end up with is going to be 6 liters. So this value here is going to be 6. I don't want to use a different variable, so I'm going to say that the difference of the 6 and the x is going to be the amount of water I need. So this is going to be 6 minus x right here. We'll then change all of our percentages into decimal notation. So 12% written as a decimal is going to be 12/100ths. And ladies and gentlemen, my percentages are percentages of alcohol. How much alcohol is in water? Exactly, ladies and gentlemen, 0%. So therefore, This is just 0 right here. Then finally, my 10% is going to be written as 1/10. Remember that it's going to be the first column times the second column that'll always equal to the third column. So I'll end up with 12 hundredths x here, multiplying x times 12 hundredths, and 6 minus x times 0. Yeah, that's just 0, ladies and gentlemen. And then finally, 6 times 1/10, this gives me 6/10. It's going to be this last column that will create my equation, ladies and gentlemen. So I'll end up with the following. I'll have 12 hundredths x plus 0 will equal to 6/10. And this is my equation. Solving my equation, I want to multiply each and every term by 100 to get rid of the decimal. But first, we can just simplify this further by saying that 12 hundredths x plus 0 is just 12 hundredths x. So I'm going to rewrite this as 12 hundredths x equals to 6/10. Then I'm going to multiply both sides by 100 to get rid of those decimals here. All right, so do not likey the decimals. Moving the decimal 2 places to the right is the result of multiplying by 100. So I'll end up with 12x equals to 60, just like so. Then dividing both sides by 12, 60 divided by 12 is 5. So I know that I'll need 5 liters, ladies and gentlemen, of my 12% solution, and I'll also need 6 minus x, which turns out to be 1 liter of water. That'll give me a final result. That'll be 10% alcohol. All right, well, this is the solution to this problem, ladies and gentlemen. So I'm going to put a red box around this. All right, and that concludes problem number 4. On to the next problem, problem number 5. Problem number 5, a pharmacist wishes to strengthen a mixture that is 10% alcohol to one that is 30% alcohol. How much pure alcohol should be added to 7 liters of the 10% mixture? So in this problem right here, ladies and gentlemen, we have the amount, we have the percentage, and we got our final mix over here. And what we'll be combining together is a 10% alcohol mixture, and we're combining that with pure alcohol to obtain a mixture that's going to be 30% alcohol. All right, so that's what we have. That's the setup. That's my table. Now let's plug in the amounts, ladies and gentlemen. In our problem, ladies and gentlemen, they told us that we have 7 liters of the 10% mixture. So that's going to be 7 for the amount for the 10%. I don't know how much of the pure alcohol I'll need in order to strengthen the mixture to a 30% mixture. Then for the total amount, you simply add 7 plus x. So I'll just write this as x plus 7 as the total amount for my 30% mixture. From there, I'll be converting every single percent into decimal notation. So 10% will be written as 1/10. If something is pure, it's 100%. Therefore, written as a decimal, that'll just be 1. My 30% is going to be 3/10, and remember, we'll be multiplying the first column times the second column in order to get the third column. 7 times 1/10 is just 7/10. Multiplying x times 1 gives me x, and then finally, x plus 7 times 3/10, I'll just write that as 3/10 times x plus 7. It's this last column, that third column, ladies and gentlemen, will help me create my equation. So this is going to be the result of it. I'll end up with 7/10 plus x equals to 3/10 times x plus 7. And this will be the equations I need for this problem. Next, I'll be multiplying each and every term by 10 in order to get rid of the decimals. So I'll have 10 times 7/10 plus 10 times x will equal to 10 times 3/10 times x plus 7. This is going to get rid of all of my decimals because multiplying by 10 moves the decimal 1 place to the right. So 10 times 7/10 is just 7 plus my 10x equals to 10 times 3/10 is going to be 3 times x plus 7. From there, I get to do my favorite properties. So I'm going to get my arrows popping. I bring down my 7 plus 10x, which equals to 3x plus 21, ladies and gentlemen. And then solving for x, I'll be subtracting 3x to both sides of the equal sign. All right, I'll bring down 7 plus 7x, which equals to 21. From there, I'll be subtracting 7 to both sides of the equal sign. And I have 7x equals to 21 minus 7 is 14. Dividing both sides by 7, we'll find out that x equals to 2. So it will be 2 liters, ladies and gentlemen, of pure alcohol to strengthen that mixture to 30%. All right, and that's the answer, ladies and gentlemen. We were looking for how many liters of pure alcohol we'll need, and that's going to be 2 liters. Done and done. That was problem number 5, and I have one last problem for you, okay? So here's problem number 6. In problem number 6, it says how many liters of 94 octane gasoline should be mixed with 200 liters of 99 octane gasoline to get a mixture that is 97 octane. When you're dealing with octane and gasoline, 94 octane is the same thing as 94% isooctane, all right? So these are percentages that we are referring to, by the way. So I'm going to set up my table with the amount, the percent, and my final mix right here. And for my rows, I know I will have 94% isooctane being mixed with 99% isooctane to get a mixture that is 97% isooctane. All right, so being as though I'm asked to find out how many liters of the 94 isooctane gasoline I should mix with the 200 liters of 99% isooctane, I don't know what that value is, the bottom line. That's my unknown. I do know that I have 200 liters of the 99 octane gasoline. So my final result is going to be X plus 200, just simply adding these two amounts together. We're going to convert all of our percentages into decimals. So 94% is the same thing as 94 hundredths, 99% is going to be 99 hundredths, and 97% is going to be 97 hundredths. Your last column is going to be the result of multiplying column 1 times column 2. So X times 94 hundredths gives me 94 hundredths X, and multiplying 200 times 99 hundredths, I'll put that on pause. All right. Finally, multiplying X plus 200 times 97 hundredths will give me 97 hundredths times X plus 200. So I'll be writing this as 94 hundredths X plus 99 hundredths times 200, and that's going to equal to 97 hundredths times X plus 200. Just like so, ladies and gentlemen. And this is the equation that I need for this problem. Solving our equation, I'll be multiplying each and every term by 100. So this is going to be 100 times this 94 hundredths X plus 100 times 99 hundredths times 200, which will equal to 100 times 97 hundredths times X plus 200. All right. Moving the decimal 2 places to the right because I'm multiplying by 100, I end up with 94X plus 99 times 200, which equals to 97 times X plus 200. Then multiplying things out and distributing, so I got my arrows popping over here, ladies and gentlemen. I'll be bringing down 94X plus 99 times 200 gives me 19,800, which equals to 97 times X, which is 97X, plus 97 times 200 is 19,400. From here, ladies and gentlemen, I'll be subtracting 94X to both sides. I'll be bringing down this 19,800, which equals to 3X plus 19,400. Subtracting 19,400 to both sides, I end up with 400 equaling to 3X. From there, ladies and gentlemen, you'll simply divide both sides by 3 to find out that you need 400 liters of your 94 octane, or you can simply simplify this into a mixed number and it'll end up giving you a value of 133 1/3 liters, ladies and gentlemen. All right, and that's how many liters you'll need, and that is going to be the answer to the problem here for problem number 6. Ladies and gentlemen, this has been Mixture Problems that deal with percentages, and this was our 11th word problem video in the word problem series, ladies and gentlemen, WP11. So as always, please rate, comment, and subscribe, and if you're able, ladies and gentlemen, please donate. Peace.
We're going to be learning about such things as linear, quadratics, system of equations, tables, mixtures, work, oh Lord, distance, interest, of which I don't have much, investment. This is my favorite one. I'm going to name my grandbaby consecutive integers. algebraic translations, and percents. I understand a little bit about percents. I know that 50% off is pretty good.